Greetings and welcome back to Room 303 in AP English and our World of Ideas lectures in Unit 5, Nature. We're now in lecture number 29. We're going to be working with Michio Kaku's The Theory of the Universe, now from 1992. Now, I'm right away going to have to talk about some assumptions. My assumptions with this lecture is that for sure at LearnStrong.net you have followed my previous lectures, especially lecture 28, where we gave some introductory comments and then talked about Stephen Jay Gould's non-moral essay. With that in mind, then if you haven't followed that, I do recommend that you go back and take a look at that before you invest some time here in our conversations with Kaku. Secondly, our assumptions about learning theory and annotative process. We're always answering those three guiding questions when we read actively and annotate. What does the text say? Of course, paragraph outlining. What does the text mean and how can I relate to it? What does the text mean? We subdivide messages, themes, our big five. What does this text say about epistemology, what we can know, ontology, who we are, psychology, the study of the individual mind, sociology, the study of the group mind, and then finally theodicy, the question of evil, pain, suffering in the world, and how can you account for it? And then, of course, at 2B, we're going to ask about rhetoric, and we're going to take a look at that from Kaku's point of view as well. And then at level 3, at 3A, can I relate this to other titles that I'm familiar with, especially, of course, the Gould text and the Dawkins text to follow. As we were saying in our prior lecture, this unit, number 5, in the Jacobus 4th edition of World of Ideas, is going to provide us first with Francis Bacon and Charles Darwin in essays, and then we're going to look at 3 really iconoclastic, really challenging writers. Kaku, of course, falls into that camp, no doubt about it. And then finally, in 3B, we'll ask, how can I relate to this information in some meaningful way? Let's do a real quick biography of Kaku. And about all of these thinkers, I hope that you will move on to do more investigation and more reading on your own. That's always our hope of any text that we study, right? He is born in 1947. As of today, as I'm giving this lecture in 2020, he then is 72 years young. American theoretical physicist. He's a futurist, often referred to, and another popularizer of science, just like Gould, and a brilliant presenter of ideas because of his spirit, his humanity, his humor. It's brilliant. He's just a brilliant presenter of ideas. Professor at City College in New York. He is a New York Times bestseller. In 2008, he published The Physics of the Impossible. In 2011, he published The Physics of the Future. And 2014, The Future of the Mind. All 3 of these volumes, I would very much recommend that you pick up and read. They are worth your time. They will make you think. And as we've said, this is what we long for as humans, ontologically speaking. We are, of course, creatures who are curious. And of course, this is one of those ways that we can approach our curiosity and our wonder by studying somebody with such a mind. He often appears on TV. Obviously, you can YouTube somebody like this and find all kinds of interviews and comments. Now, this essay we're looking at appeared in 1992. Ideas produced from a text called Hyperspace, the 1994 book. One of the things I'm going to challenge you to do, because this essay is an older essay, is to study how much has evolved since even this essay was written about understandings of the universe and our lack of understanding of the universe. It's quite a compelling thing. I mean, those of us who are Ken Wilber fans, we love to read Quantum Questions, his classic text that kind of resurrects that whole notion from the words of actual physicists about how little we actually understand. And that's frightening, but it's also really exciting, right? I mean, it should excite you that really brilliant people who have spent their whole life studying this stuff will often say, I got no idea. I have no idea how this happens. I'm just trying to, as much as possible, run it to ground. Let's just go to what Jacobus has to say about Kaku for a few moments. I'm on 431. In an early chapter of Hyperspace, Kaku tells a story about a young boy and watching fishing, or watching fish in a small pond. He realized that for the carp, it was inconceivable that he or anything outside the water in which they swam could exist. We think about Plato's cave allegory, right? Their preconceptions were limited entirely to the watery environment they called home. The same is true for people. Our environment may seem larger and more capacious than a pond, but we, like the carp, are limited in our perceptions. And then, of course, Jacobus will mention Plato, because, of course, we have been studying Plato in an earlier lecture. Plato realized this when he postulated his allegory of the cave and theorized that our profoundly limited sensory apparatus prevents us from even imagining experiences beyond what we know from our senses. Think about even the way we think about the future. I mean, Jordan Peterson has said a lot about this in his lectures on the book of Genesis. That very notion that humans evolved to the position where we could talk about a future self that's in the future. I mean, you guys think about, what is it going to be like when I graduate from college? That's a future self. How can we even imagine that? Very difficult to do that. Why? It's not a part of our immediate environment, is it? Right? Now, to continue, in Kaku's theory of the universe, we come across a similar anomaly. We are used to living in the three dimensions of space and the added dimension of time, and we find it impossible to imagine a fifth dimension. To an extent, this echoes some of Maimonides' concerns, an earlier lecture, of course, that we've given already, about the limits of the human mind. To resolve conflicts between the major theories of explaining the universe, the quantum theory and the theory of relativity, we need a mathematics that postulates more than 4 dimensions. Fortunately, mathematics describes what our natural senses regard as inconceivable. According to Kaku, 10 dimensions are needed to resolve conflicts in modern theories and accurately predict the behavior of subatomic particles. Again, go back now and you can do some research to find out how much of this has even evolved since this was written by Jacobus. Kaku's explanation of this phenomenon defies common sense, but as one theorician has said, it's a theory that may be crazy enough to explain the true nature of nature. Again, we used the term iconoclast in the last lecture, and no question about it. And then Kaku, of course, is going to explain the superstring theory as tiny strings of energy that have an infinite number of variations, thus explaining why protons that collide in supercolliders seem to release so many particles. And as we pointed out, even the use of the word energy so cavalierly by scientists has got to be challenged by us to say, what exactly do you mean when you say energy is that which can be neither created nor destroyed? I mean, so it doesn't exist. No, it definitely exists. You just said it can't be created or destroyed. How do you use language like that without smiling? Well, it's the myth, of course. It's the attempt to explain the unexplainable. To admit that doesn't make it wrong. It just simply makes it more real. That is to say, fallibilism is epistemologically a position that Kaku is certainly going to take, although it's going to seem kind of crazy or insane, right? I mean, go back a few years ago and try and tell somebody that, we're going to walk on the moon, and they would say that's absolutely impossible, right? In the same way that today we say it's absolutely impossible to live to be 200 years old, right? That is to say, sometimes crazy is not crazy. Or, as Emily Dickinson says in Much Madness is Divine as Sense to the Discerning Eye, go back and take a look at that lecture. Insanity or sanity is always, it seems, dependent upon a majority. This, if you're going to differ with the majority, you're straightway dangerous and handled with a chain. You can go back and take a look at that lecture on learnstrong.net. Now, in terms of rhetoric, let's pay attention to that for a moment. Jacobus points out this is a very journalistic styled technique, the short paragraphing, the use of the subhead. We are going to challenge you to pay very close attention to the notes in this essay, because Kaku's going to make some references to things that maybe we're unfamiliar with. Just to finish on 433, the essay is not an argument, Jacobus points out. Kaku is not trying to convert quantum theorists or relativists to his new view. Instead, he's interested primarily in describing the choices that permit the reader to participate in the discussion. To be sure, he believes that the superstring has the capacity to explain the workings of nature and the universe, but since it can't be proved experimentally and is likely to remain theoretical, he hopes merely to describe the theory. When more work is done on it and more analysis is available, the theory may or may not hold up. But for the moment, Kaku tells us common sense is out and craziness is the new paradigm in modern physics. And a whole lot was made of this notion of the paradigm shifts. A theorist named Thomas Kuhn made this paradigm shift idea a big deal. And it is true, a whole lot's been done since this essay. So this essay is in some ways outdated. But the reason why I love to study it is because rhetorically, it presents so brilliantly controversial ideas in the most magnificently humane tone. So pay attention to that as you read this essay. Let's work through it now at level 1, paragraphs 1 through 12. We've got 81 paragraphs in this essay, but notice they're very short. Paragraphs 1 through 12. He says, as a child, he begins with a personal bit of biography. Notice writers often will do this. As a child, I was fascinated by Albert Einstein's search for a theory that would unite all physical laws into a simple framework. This theory eluded Einstein and others, but today some scientists claim to have found such a theory, one that explains the 4 fundamental forces in the universe. Paragraphs 13 through 22. These forces are gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. And of course, if we're studying in our physics class, we're familiar with these concepts. Our understanding of these forces has produced major changes in civilization. The next question is whether a single superforce unites them all. Just to pause for a moment. Remember what we said about Mortimer Adler and how to read a book? Reading science is different from reading Shakespeare. I mean, as you go through this, just notice how this is quite different from reading a story by Faulkner, for example. All right? And yet, interestingly, you're going to use some of the same skill sets that you're developing back and forth between the two. I mean, to pick up Sound and Fury is sometimes more difficult than reading anything like Kaku's producing here. Paragraphs 23 through 31. There are currently 2 widely accepted theories that explain how the 4 forces work. The quantum theory, the general theory of relativity. The quantum theory explains the electromagnetic force as well as the strong and weak nuclear forces by describing the behavior of subatomic packets of energy called quantum. The general theory of relativity, of course, explains the force of gravity by describing the curvature of space-time. The problem facing scientists is to merge these 2 theories, which offer different and seemingly irreconcilable explanations of the physical world. And of course, since Kaku wrote this essay back in the early 90s, a whole lot's been done on this, as you can research. Paragraphs 32 through 38. Some scientists have proposed a solution to superstring theory, which postulates that all matter and energy can be reduced to tiny strings of energy. Superstrings vibrate in different frequencies, much like strings on a violin. These vibrations are the subatomic particles whose behavior is described by quantum theory. At the same time, the vibrating strings cause surrounding space-time to curve in a manner consistent with the general theory of relativity. Thus, superstring theory merges the 2 theories, quantum and relativity, providing a single explanation for all known forces in the universe. It's an interesting concept. Excuse me. Paragraphs 39 through 49. The most controversial aspect of the superstring theory is its prediction that the universe has multiple dimensions. We conventionally understand space as having 3 dimensions: height, depth, width. Some scientists claim that our universe has a 4th dimension we can't visualize. From a mathematical point of view, adding this dimension allows scientists to describe a greater number of forces and to unify the laws of physics. Paragraphs 50 through 55. According to superstring theory, the universe has initially 10-dimensional, but then broke into 2 parts. One part, the expanding 4-dimensional universe created in the Big Bang. The other part is a 6-dimensional universe that collapsed into an infinitesimal tiny ball. Paragraphs 56 through 59. And some readers of this will say, well, this is just like reading myths, stories to explain the unexplainable. Why not postulate? 56 through 59. Some scientists reject the superstring theory because it can't be tested, because the theory claims to elucidate the workings of all forces in the universe, including creation itself. Testing it would require the impossible, experimentally reconstructing the instant of creation. And of course, since this essay was written, there are scientists who are trying to do that very thing that is claimed to be impossible, that is to say, reconstructing the instant of creation, right? Paragraph 60 through 64. It may be possible, however, to test some ideas about the instant of creation using the superconducting supercollider, the SSC, which is under construction. This enormous machine will generate, and now today we say does generate, temperatures that have not been reached since the instant of creation. Even if these experiments fail to verify the superstring theory, they may give indirect evidence to support it. 65 to 73. We have a parable about a gemstone that illustrates the difficulty of merging the quantum and the relativity theories and shows why the superstring theory is so controversial. And then finally, to finish, in paragraph 74 to 81, supporters of the superstring theory argue that the fundamental problem is theoretical, not practical. Instead of building the SSC to verify the theory, we should work to understand the theory itself. Unfortunately, he says, the mathematical tools currently available are inadequate for the job. If anything, what Kaku is doing. Now let's jump to level 2, A. And our big 5, epistemologically, no question, challenging the absolutist position often held in hard physics, and to say, maybe a fallibilist position is in order even for us in the hardest of sciences. Ontologically, well, I think it's clear, Kaku is arguing, we love a puzzle. Even though it's a conundrum that forces us into frustration, we still love it. We're hardwired that way, ontologically it seems. Psychologically, what we don't understand can obviously freak us out, frighten us, or kind of make us a little bit weary, right? Which obviously part of the tone of this essay is, let's go ahead and pursue lines of thought even though we're not absolutely sure where they're going to lead. Sociologically, the obvious idea here is that we got to work together. There are some questions that one cannot come to on one's own. I would argue that is the point of studying and reading in the humanities and in the sciences. To keep discovering, right? Theodictically, what does this say about the existence of pain and suffering in the world? We can't always understand, right, the causes of pain and suffering. I think Kaku is seeming to suggest in this essay. But we have to keep trying to find the answers. At 2A, that is the message, right? Keep asking questions. Love to learn. And a little craziness is okay. That is to say, you got to learn how to think outside of the box if one is going to really solve problems. And what is it that we're trying to do in school? Think about that. We're trying to develop a way of thinking, a habit of thinking that can allow for innovative thinking, right? Creative thinking. And the only way that happens is to admit, sometimes an idea is going to start out kind of crazy. Hey, let's figure out a way to fly. And then maybe someday step on a moon. Or someday put something on Mars so we can study it. That is absolutely impossible. See, today we roll our eyes and say, So the next time somebody tells you that can't be done, just remind yourself, yeah, in the history of great ideas, oftentimes the thinkers and groups of thinkers, back to our sociological observation, we're told it can't be done. At 2B, the organization here, right, the ability to explain difficult concepts, the use of word pictures are powerful as well. And then again, the tone, very readable, challenging, very respectful. Have you noticed that? Very respectful. Of course, at 3A, Plato's cave allegory, Bacon's four idols, all of those have to come to mind. Earlier lectures. Hey, how about this? Remember what Hamlet says to Horatio at the end of Act 1 and Scene 7? There are more things in heaven and earth that are dreamt of in your philosophy. I think that's a compelling line any time that we pick up the study in the humanities and obviously the sciences and the maths as well. And finally, 3B, what was a time in your life when crazy, some kind of crazy idea, ended up seeming not so insanely crazy at all? Some of you are smiling because you would say taking an AP class might be one of those. How about this one? Are you okay with not knowing or understanding something? Is that all right for you? Or are you an individual that's made very uncomfortable when somebody asks you a question you don't have an immediate answer to? Of course, the problem is that our life is constructed 80+% of the time by questions we don't always have clear answers to, right? I'm going to do this. I'm going to major in this. Is that going to give me what I want? No way to know until you try. Which is why some of us are paralyzed to never do anything, which it seems to me, and I agree here with somebody like Jordan Peterson, it seems to me this is the bad approach. The right approach is to say, I'm going to try something even though it's going to be wrong. And I'm going to try it, and if it doesn't work, I'm going to try something else. The scientific approach, right? Well, there you go, the great Kaku. I hope you'll go on to maybe enjoy more of his stuff and do a bit of research yourself. Thank you.